Okay, now we're back with example number 5. The table below shows the results obtained from experiments to determine the boiling points of some alkanes. Alkenes, alkanes, and alcohols of similar weight. So if you take a look, we have a ethene, then we have a methanol, then we have a propene, then we have a ethanol, then we have a butene, then we have a propanol, then we have a butene, and then we have a butanol. So if we look there, the relative molecular masses is increasing from top to bottom. The boiling points, if you look at the alkenes, that is number 1, 2, 3, and 4, you will see the boiling point is increasing as the number of carbons is increasing in the chain. And then with the alcohols, exactly the same thing. You will see as we increase the number of carbons, we have an increase in the boiling point. So, consider the boiling points of the 4 alkenes in the table below. Describe the trend in their boiling points. So, if you look at the 4 alkenes, if you increase the number of carbons, what happens to the boiling point? It also increases. Explain the trend completely. So number 1, we need to identify the intermolecular forces, and in an alkene we have the same intermolecular forces. It's very weak intermolecular forces, induced dipole forces, or London forces. And then we will say the strength as you increase the number of carbons in the chain, you increase the strength in the intermolecular force. Then if we go on, we need to say, so more energy needed will be needed to overcome the intermolecular force in the pentene than in the butene, than in the propene, than in the ethene. So there's more energy needed in our 5 carbon compound than in our 2 carbon compound. So what does this mean? It means that the boiling point will increase if we add more carbons in the longest carbon chain. 5.2, the boiling points of each alcohol is much higher than that of the compared relative mass. Explain the observation by referring to the type and the strength of forces in the alkanes and in the alkenes. So we need to compare now the alcohols and the alkenes. So number 1, the alkenes has induced dipole forces. The alcohols has hydrogen bonds. Then we need to compare. The hydrogen bonds is stronger than the induced dipole forces, meaning that the boiling point will be much higher than that of the alkenes for the alcohols. That means more energy needed will be needed to overcome the intermolecular forces in the alcohols than in the alkenes. 5.3. Consider the boiling points of the 4 alcohols in the table below. Describe the trend. The same. You will see the more carbons there is in each structure. If you look at CH3, it's 65, then CH3, CH2OH, 78. So it's increasing. So as we increase the number of carbons, we have an increase in the boiling point. Explain the trends in question 5.3.1 completely. So number 1, we identify the forces. All of them has hydrogen bonds. But what's the difference? There is more carbons in the carbon chain. So if we increase the length of the carbon chain, what are we doing to the intermolecular force? It becomes stronger. So the longer the carbon chain, the stronger the intermolecular forces. So the pentene will have a stronger intermolecular force than the butene or the propene or the ethene or the methanol. So, sorry, we're talking about the alcohols. So, let me just repeat. The pentanol will have a stronger intermolecular force than the propanol. And the propanol will have a stronger intermolecular force than the ethanol. And the ethanol will have a stronger intermolecular force than the methanol. Alright, so we've compared the strengths. So more energy will be needed to overcome the intermolecular forces in a longer carbon chain than in a shorter carbon chain. This will then have an implication that the boiling point will be at its highest in the longest carbon chain. Example 6, we have 3 structures, and this is a very interesting question because we have a long carbon chain, then we have a branched structure, and then we have a more branched structure. So according to what we know is that our branches will lower the intermolecular forces. But look at the melting points. Heptane has a melting point of minus 91. 2-methylhexane minus 118. But then suddenly there is an exception. You can see that trimethylbutane suddenly has a minus 26. So now, if we look at this, we're going to see that in the answer, we're going to change something here if we look at the melting point. So why are these compounds structural isomers? They have the same intermolecular force, but they have different structural formulas or different chain lengths. 6.2. By comparing these boiling points of 2-methyl and 2,2,3-butyl, which of these compounds has the highest vapor pressure? So if you look at the boiling points for 2-methylhexane, it's 90, and for 3-trimethylbutane, it's 80. So if you look at that, the vapor pressure of the 2,2,3-trimethylbutane is the highest, and then the vapor pressure for 2-methylhexane is the lowest. How do we know that? If you look at the molecular structure, if you look at the intermolecular forces, both of them has induced dipole forces, but because there is only one branch in 2-methylhexane, we will see that there is stronger intermolecular forces in the 2-methylhexane than in the 2,2,3-trimethylbutane. So more energy will be needed to overcome the intermolecular forces in the branch. Now if you look at 6.3, 6.3 is the one that we need to look at. If we go and compare heptane, heptane will be a liquid. 2-methylhexane is a very it's not a symmetrical compound, but if you draw this compound, it will be symmetrical. So this will easily form a solid, while these two will not as easily form a solid. So the reason why there is a difference in the melting points is because of the structure of these compounds. So 2,2,3-trimethylbutane is actually an exception to the rule. That is why it will not follow the trend, because this was supposed to be the highest melting point, but because of the structure, it's easily forming a solid. So that's why it has a very low melting point. So here the intermolecular forces is the same as in 6.2, but because of the structure of the compound, we have different structural formulas. If we look at example 7, which compound? We have 3 structural formulas. We have a primary alcohol, we have a secondary alcohol, and we have a tertiary alcohol. Remember, if we talk about a primary, we look at the carbon there. It's bonded to one other carbon. Then we talk about B, the carbon there, 1 2 other carbons, and then the carbon here, 1, 2, 3 other carbons. Okay, so this is then a tertiary compound. So which compounds, A or C, has the lowest melting point? Give a reason for the difference in the boiling points. Refer to the intermolecular salts. So if you look at A and C, we are saying that A will have the highest boiling point and C will have the lowest boiling point. Why? Because we have that the intermolecular forces in both is hydrogen bonds, but the one is a straight carbon chain and the other one is a branch chain. So if the branch chain will have lower intermolecular forces than the straight carbon chain, and that means more energy will be needed to overcome the forces in A than in compound C. Which of A, B or C has the lowest vapor pressure at the same temperature? So the lowest vapor pressure is the one with the weakest the one with the highest intermolecular force, and that will be compound A, because it has a long straight carbon chain. I think we must just look at B as well, because B is a secondary carbon. So this has to do with the secondary carbon. So B is actually one with the lowest vapor pressure because it's a secondary carbon. It will then have more intermolecular forces than A and C. Is the boiling point of compound A higher or lower than that of pentanol? It's definitely higher than that of pentanol. Explain your answer. A has hydrogen bonds, pentanol has dipole-dipole forces, so the dipole-dipole is weaker than that of the hydrogen bonds, meaning the hydrogen bonds needs more energy to overcome the intermolecular forces than the dipole-dipole forces, and then we will have that A has a higher boiling point than the pentanol. Okay guys, so we will talk tomorrow again when we look at some videos. Please follow these links of the videos to my YouTube page. Thanks for joining us. Enjoy the day. Goodbye.